Hello everyone, welcome back to our channel. In today's video, we are going to perform one real SOC attack simulation using one of the most commonly abused Windows binary called Rundll32.exe. So first we can create one fake software download website on our Kali Linux machine. Then we can download the file on Windows victim machine. Then we can execute and we can collect the logs and we can execute and we can do the investigation. So first in the Kali Linux machine, we can create the folder called rundll32lab. So this folder will act as a attacker web server. So inside this folder, we are creating index.html page. So this is simple web page that looks like a software download site. The page will display like a download now button, and when user click on it, it will download the zip file called pdfconverter.zip. So now we are creating the another folder called pdf converter under the same folder like rundll32 lab. Under this we am creating the pdf converter. So inside this folder we can create one batch file called install.bat. So let's understand what this batch file will does. So in this batch file I am mentioning like the script. It will install one fake message and it will wait for the 3 seconds and then it will execute the following command like a run dll32.exe shell32.dll and control underscore run dll. In the screen you can see the same thing I mentioned. So based on the script, it will wait for the 3 seconds and then it will execute this command. So this command will open the Windows control panel. We are using a legitimate Windows DLL so that we can safely generate the process creation logs without executing any malicious code. So after creating this batch file, we are compressing this folder into pdfconverter.zip. Yeah, we are converting this folder into zip folder. And this is only for education purpose. So now I am checking the files and folders what are available in this run DLL32 lab. So let's say now we can run the Python HTTP server on the Kali Linux to execute the attack on the victim machine. So I am running the command Python command to connect to the web server. So here you can see the command Python. So now let's move to the Windows victim machine and run the IP address or URL. So I'm using the Kali Linux web server, right? So I'm using the Kali Linux IP address and semicolon web server 8000. So the web machine will open the display download button you can see. So once you click on the download, it will download the pdf converter.zip file. So go to the download folder and we can extract the zip file into the same path. So I'm extracting it. Yes. So inside the extracted folder, we can see install.bat. See here you can see whenever we double click on the batch file, it will Windows open the command.exe, and here you can see the command from. The same thing we can see in the Splunk logs also. So the command prompt then execute the batch file. Finally, the batch file executes run dll32.exe. At the same time, Sysmon will record every process creation event, and Splunk Universal Forwarder send these logs to our Splunk server for the further investigation. Okay, so it's executed command.exe and control panel open. Now let's move to the Splunk search. So now I am searching the index equal to Windows for last 24 hours. So in Splunk search, we can see a lot of the events. Almost 29,000 events are there. So since this is a process creation and rundll32.exe, so we are checking the source type equal to Sysmon. So I am defining the search filters to get the more accurate results. So now I am applying the table with the event code, computer name, user, and the process image and process parent process. So we are executed rundll32.exe and command.exe. So I am checking the same thing. So we have so many logs. Under these we can see where it is. Yeah, here you can see run dll32.exe and the parent image is command.exe and these commands are run dll32.exe. The same thing we mentioned in the back file. So if you remember while executing this, again I am showing here in the notepad. In the notepad you can see that back file. the same command, whatever we command executed, the same thing we can see in the Splunk logs. So now we can check the command.exe. See here, command.exe, and the parent image is explore.exe and the command line. So again I am executing this one. So from here you can see that the command from where it got executed. So install.bat. So the from address you can see C users admin downloads and PDF converter. The same command you can see in the Splunk logs. See this one from address. Okay, let me run this one and I am closing the command prompt. Let's move to the Splunk, and under command line you can see the same path C users admin download PDF converter and PDF converter dot converter slash install.bat. So since we required only command.exe and rundll32.exe, so I'm refining the search and I'm searching only for these two paths, command.exe and rundll32.exe. So that's why I'm applying the filter image equal to command.exe or image equal to slash rundll32.exe. So it will give, like, it will filter the logs and it will give only which are related to the command.exe and rundll32.exe. So it's easy to understand the process and we can do the investigation properly. So see, from the logs you can see, looking at the parent process, we can clearly see that explore.exe is launched by the command.exe. So this is tells us user manually executed the batch file. So next we can see command.exe is launched by the rundll32.exe. So this command line shows rundll32.exe shell 32. So let's understand the process tree. Explore.exe, command.exe, install.bat, and rundll32.exe. So this process chain extremely important because it shows how execution started. So we also notice that there are some legitimate Windows background activities. So SOC analyst should never assume that every rundll32 process is malicious. So instead we investigate the parent process, command line, and execution path user context. Please follow this channel for more SOC updates. Thank you.